We're going to solve project Euler problem 19. In this problem, the question to be answered is how many Sundays fell on the first of the month during the 20th century. In order to do that, I prepared a little data type called date, and the date consists of a year, a month, a day, and a day of week. Day of week means like just a day like Monday or Wednesday, and it is represented as a number from 0 to 6. So I want to iterate over all the days in the 20th century and count how many of them have their are a first of a month and are in fact a Sunday. So in order to generate every date in the 20th century, I will define the following method, the following function called nextDate, which will take a date and return a date. And this function can look as follows. We are given a date that has a year, a month, a day, and a day of week. We will call this date D. Now, if a day is the last day in a month, then we need to count up the months, obviously, because we're entering a new month. So if is last day of month, then we will increase, then we will just return another date with the day set to 1 and the month increased by 1. Obviously the day of week has also to be increased, but so we will increase that by 1. But if we are at Sunday, then we want to jump back to Monday, so we will do this calculation modulo 7, which will do just that. Alright. Now obviously this will only work if we are not on the last day of December, because on the last day of December we also increase the year and set the months back to 1. So if month equals 12, if we are in December, then we will actually return something else. We will not return this, but we will set the month to 1. Day to 1, and the year will be increased. Alright, so let's format this a little bit nicer so that we can see what's going on. On every other day of the year, if we are not in the last day of a month, then we can just count up the days. So let's do that. Mon and, well, day plus 1. Alright, so now we use the predicate is last day of month, but we didn't actually define it, so let's do that. This will take a day and return a bool. And we will do a little pattern matching here. Year, month, day. And day of week, which is not interesting in this case. Now, when is a day the last day of a month? So months have different lengths. For example, if the month is an element of these months, these are the months that contain 30 days. This is April, June, September, and November. And the day is 30. The day is the 30th. Then of course we are at the end of the month. when the month is a month that has 31 days, which are the following ones: January, March, and so on. Let me just type them in real quick. Then and if we are on the 31st, then of course we are at the end of the month. Now there's a special case of February. So if we are in February and we are in a leap year, then the month only has 29 days. So if we are in leap year, which we can determine as follows: if the number of the year is divisible by 4, and if we are on day number 29, like that, then we return true. And the same way we do the same if we are in a non-leap year. So if the year number is not divisible by 4 and the day is 28, because in that case February has 28 days. Alright, so let's go ahead and generate the list of all days in the 20th century. So we can do this as follows: date, a list of dates, and in the problem statement we are given the following fact: the 1st January of 1900 was a Monday. So we can start at that date. So first of all we will need to construct that. Year 1900, January 1st, and that was a Monday, which we represent as a 0. Now we will generate every possible date upwards from that date by using iterate, and we iterate the function next date. Now of course this would give us infinitely many dates, which we don't want. We only want to take them while we are not in the year 2001, because that would be the start of the 21st century. So we take while the year of a day is not equal to 2001. And also you notice that we start in the year 1900, but we actually only want to count the dates in the 20th century, which starts in the year 1901. So we have to drop a few dates. We will drop the dates while their year is 1900. So if year of D is equal to 1900, then we drop it. Alright, so these are all the dates that we will inspect, and now we will count how many of them are interesting for us. So interesting dates. Is now also a list of dates. Of date. And these are all of our dates, but we will filter them in a certain way. So we filter them according to the following criterion. We allow a day if it is the 1st of the month, so if day is 1, and if the day of week is a Sunday. So if day of week is equal to 6, because Sunday is the 6th day in a week. Okay, now we can write our main method, and we are basically just going to print out the length of the interesting dates. So let's compile this. And run it with time. And as you'll see, we get the correct answer in 0.02 seconds. Thanks for watching.